Greetings and hello. My name is Mohammad Faris bin Hussain. So our group is presenting our software economics project, evaluating the pay and go smart city parking system using the issue value framework. So before we look at the specific models, it is important to know our global fixed variables. Like for the system operational infrastructure, the app developer incurs a fixed expense of 80 ringgit for server maintenance and administration. So let's look at how value is distributed in our baseline model. So the objective of our baseline model is to map out the standard value transactions under normal daily operations before any external changes occur. So in this baseline network, we set our market segment for the standard citizen at count of 100. So how does the flow work? So the citizen pays a parking fee of 3 ringgit to the app developer in exchange for utilizing physical parking space and digital services. And then from the transaction, the app developer passes an agreed parking revenue of 2 ringgit per transaction to the city council. So in return, the city council grants the app developer the official license to operate the platform. So when we look at the financial outcome with 100 citizens and subtracting the 80 ringgit fixed expenses, the model yields NPV of plus 20 ringgit for the app developer and plus 200 ringgit for the city council. So this proves our core baseline architecture is fully profitable and mutually beneficial. For the scenario 1, we introduce a social constraint representing the digital divide where the city council implements a policy providing a 50% parking discount for elderly citizens aged 60 and above. So this adds a new elderly market segment of 10 users to our initial 100 standard citizens. So to protect the system viability, we introduced a subsidy loop. So the elderly segment pays a discount fee of 1 ringgit and 50 cents to the app. So to cover the gap, the city council pays an EEP subsidy of 1 ringgit and 50 cents back to the app developer. So this allows the app developer to continue remitting the standard 2 ringgit parking revenue to the council for all 1 ringgit and 10 total users. So the important here is that the model is highly robust. So factoring in the expanded volume, the app developers NPV increases to plus 30 ringgit and the city council's NPV rises to plus 205 ringgit. So the subsidy loop successfully shields the developer from losses while allowing the council to fulfill its social welfare duties profitably. So that concludes my part. So I will now pass to the next presenter.
Hello, my name is Shiffa Binti Azahar and my metric number is 85185. So I'm going to present for scenario 2, financial resilience. The purpose of this scenario is to test whether the pay and go business model can still survive when user traffic drops significantly. In this case, the scenario is called the ghost town because of a drop of 40% in the original user where only 60% of the original user are still using the parking service. Based on the diagram, there are three main actors involved, which are citizen, the app developer, and the city council. The citizen pays parking fee of 3 ringgit through the application. In the return, the citizen receives access to parking space or parking service. Then the app developer transfer part of the parking revenue to the City Council. For each transaction, the City Council receives RM2 as parking revenue. In the return, the City Council provide the app's developer with the license of operated the parking service. Next, for the profitability analysis, there are 60 citizens using the system in this scenario. Since each citizen pay RM3, the total money received by the app developer is RM180. However, the app developer needs to pay RM2 per user to the City Council, which means the City Council receives RM120 in total. After considering the app developer fixed operational price, which is RM80, the final results show that the app developer MPV is negative RM20. This means the app developer is making a loss in this scenario. On the other hand, the City Council MPV is positive RM120, meaning the City Council still gain revenue from the parking transaction. The conclusion for this scenario is that the business model has low financial robustness when user adoption is low. The app developer depends heavily on having enough users to cover fixed operational costs. When the number of users drops by 40%, the platform cannot generate enough profit because financially risky. This shows that the business model may need an additional income source, more user, or cost reduction strategy to remain sustainable during low demand situation. Next, scenario 3, business model adaptability. This scenario focuses on how the pay and go business model can adapt by changing its main revenue source. Instead of depending on the parking fee commission, the app developer changed the strategy to generate income through B2B data monetization. In this diagram, there are 4 main actors: citizen, app developer, city council, and local businesses. The citizens still use the application to pay for the parking. There are 100 citizens and each citizen pay RM3 as the standard parking fee. This means the local parking fee collected in RM300. In this scenario, the app developer does not keep any commission from the parking fee. Instead, 100% of the parking revenue is transferred to the City Council. This means the City Council receives the full RM300, which increases the City Council financial benefits. To replace the lost parking commission, the app developer sells anonymized traffic data to local businesses. This data can help local businesses understand traffic flow, customer movement, and parking activity around certain areas. In return, the local businesses pay the app developer RM150 as data revenue. After considering the app developer fixed operational cost of RM80, the app developer still achieve a positive MPV of RM70. This is because RM150 data revenue minus RM80 fixed cost give the app developer a profit of RM70. At the same time, the City Council receives RM300, which is higher compared to the previous scenario. Therefore, this scenario is considered highly robust. The app developer is no longer dependent on parking fee commission and can still make profit through data subscription. The City Council also benefit because it received the full parking revenue. Overall, scenario 3 shows the business model become more sustainable and adaptable when it includes a secondary revenue source such as B2B data sales.
Hello, I will be presenting scenario 4 for this project. In this case scenario, we want to know what actually happened if the smart camera fails and 50% of the people park for free. Here is what actually happened. As usual, the default value for the test is 100 people, when in this case only 85 people actually pay for the queuing parking fee. So as a result, they only collected RM255. This time, the app developer managed to pay the City Council their parking revenue for the only 85 cars that paid the parking fee, which is RM170. After the app developer paid the RM2 server cost, the app developer is left with a tiny profit of just RM5. Now the question is, how does this link affect our relationship with the City Council? In our model, a good relationship means both sides feel that it is fair. So in a normal case, the council expects to make RM200 because the camera are not working properly. They only make RM170 here, where they lost RM50 from the 15% rate. Because of this, the City Council will not give the app developer their license to operate. So we shall pick the camera camera immediately to gain the trust and keep the service going. Next is scenario 5. We wanted to see if we could make more money with us in the city to build more parking spots. We created a smart refund where the rule is very simple. So if the car leaves the parking spot early within 15 minutes, the app gives them 50 cents back. So here how the math works. First, 100 people park and pay the 3 ringgit each. So that is 300 ringgit. Then let's say the cashier is 20 people decide to leave early. We give them the 50 cent back, which will be total up to 10 ringgit for the 20 people. Because they left, 20 empty spots open up and 20 new people can fill those parking spots and pay the full 3 ringgit. So that is Sekelie total. So for overall total we collected a total of 350 ringgit. And as usual, the council get the 200 ringgit council revenue and the app developer pay the 90 ringgit server cost. So the final app developer profit is 70 ringgit. Now this brings us to the final question. Does having two people pay for the same spot increase the total profit? Yes, in this scenario testing, one parking space on one time pass like a maximum of 30 ringgit. But with the smart refund tweak, the first person is the early river, pay for 3 ringgit and get the 50 cent back, and we get to keep 250 cents. Then the new person comes in and pay the full 3 ringgit parking fee. That means our tax case is made 5 ringgit and 50 cents from a single piece of parking space. By this smart refund trade, we get the car to be faster, fit more customers into the same parking spot, and make everyone more money.